Good day, viewers. Today we will be looking at simplifying the algebraic expression that is being shown above. We will be simplifying m cubed n minus 2m squared n squared all divided by 2m n cubed minus m squared n squared. I'd like you to take a minute or two, pause this video, simplify this algebraic expression, and then put your answer in the comment section. I'd like you to put your answer in the comment section. I was given this algebraic expression a short while ago by a family friend, and I learned one or two lessons from this particular algebraic expression, and that's one of the reasons why I'm sharing it with you, so that you can also learn one or two things. So what we will simply do is to write out the algebraic expression and then look at how we can factorize or bring out common factors. So we will start with the numerator. We will start with the numerator, that is all the expressions above the division sign, and then later we will look at the denominator, that is all the expressions below or under the division sign. So let's start by looking at m cubed n minus 2m squared n squared. That is, as I said earlier, the expressions written as the numerator. The expressions written as the numerator. So we have m cubed n and we have 2m squared n squared. So what do we have that is common to this and also common to this? Now we have n common to this and we have n squared. So what is common to both of them is n. So we'll take out the n. Remember, when we take out the n, we have m cubed left here, and then we have 2m squared and then a single n left. But if we look at them both, we will also see that there is an m squared and m squared that can be taken from this, and also that can also be taken from this. So we have an m squared and an n that is common to both of those expressions in the numerator. So when we bring out m squared n, which is the common factor, or which are the common factors, what do we have left? So we take an m squared from this and an n. So if we take the m squared from this, we're left with an m, which is the m that is left in the brackets. And then if we take an m squared n, m squared cancels out, the n cancels out, we're left with an n. So we are left with minus 2n. We are left with minus 2n. So we have simplified the numerator by taking out m squared n from both this and also this other parameter here. Now we'll do the same for the denominator. Now what are we going to do? What do we have that is common to this and also common to this, such that we can bring it out as a factor? n squared is common here and is also common here. M is here and also can be seen here. So we'll take out mn squared. We'll take out mn squared. Let me just make a comment here. We have n cubed here, but we have n squared here. We can't take n cubed from here and also take n cubed from here. What is common to both of them is n squared. So we can take an n squared here, and then we can take an n squared here, and then we'll be left with n here. Here we have an m squared, and here we have m. M is common to both of them, so we have mn squared, and that will be our factor, which we will bring out from the denominator. We'll be bringing out that from the denominator. And when we do that, you remove your m and an n squared here, you're left with 2n. And then when you remove your m from here, you have one m left, and when you take your n squared, so you only have the m left. So that's why we have mn squared into the bracket 2n minus m as the simplified form of the denominator. And then if you look at the numerator, we have m squared n, and then we have into the bracket m minus 2n as the first phase of the simplified numerator. So this is what we have right now. Let's see how we can further simplify. Now, if you look at this, you have an m here, and then you have m squared. So m here can cancel one of the m's above. So we're left with a single m above, that is in the numerator. And then you have an n here, which can cancel one of the n's here. So we'll have an n left as part of the denominator. So we have m over n. So we can simplify that to be m over n. And then we still have the m minus 2n as part of the numerator, and we have 2n minus m. So this is the simplified version, once again, from what we have above. So one of the lessons I wanted us to learn is you may think that you can stop here, which is actually simplified. But if you take note of 2n minus m, and you also take note of n minus 2n, you see that there's something that is common to both the numerator and the denominator. So if you bring out the minus sign here, you see that this 2n plus minus m will begin to look like what we have in the denominator. So let's do that and see what we get. Take the negative sign from the numerator. So we now have minus m minus m. So in the numerator, this now becomes, because the negative sign has been taken out, this minus 2n now becomes plus 2n. And then this plus m now becomes minus m. So if we simplify, that's what we have now. So we now have 2n minus m. And then we just bring down the denominator as it is. You will observe clearly that 2n minus m is what we have here, and is also what we have here. That is both as the numerator and denominator. So they can cancel out. And when they cancel out, what do we have? We have let's simplify further. So what do we have at the end of the day when we finish the simplification? We have it as follows: minus m over n. So this cancels out this, that is 2n minus m, at the top cancels out the 2n minus m below. They cancel each other out, and then you have minus m over n, which can also be expressed as minus outside m over n. Now, I'll just quickly show you something, and some quick observation as we solve this problem. So we've actually gotten the answer, which is minus m over n. But I just want to also show you another perspective. So we've solved it to this extent, if you remember, at some point in time. Now, getting to this particular point where we are here, I can decide to bring out the negative sign from the base. So if I bring out a negative sign, minus 1 here, you know that this now becomes m minus 2n. So if I bring out the negative sign, this negative sign now become positive, and this 2n will now become negative. So it will now become m minus 2n, which looks like what is on top. So let's do that and see what happens. So what we're simply doing is bringing out the negative sign at the base. So we now have minus n, and now becomes into m minus 2n. Now you see that m minus 2n and m minus 2n here cancel out, and then you have m over minus n. So you have m over minus n. So this cancels out this, so you have m over minus n, which is also the same as m over n with the negative sign, so minus m over n. So our solution to this particular algebraic problem is minus into m over n. Thank you.